Okay, guys, we're back here on the Cengage curriculum for the CNC mill operator exam. Um, and kind of where we left off here was um, we had a few days ago done a precision measurement review on how to use calipers and micrometers to take precision measurements. What we're going to be moving into is some of the basics of how a CNC machine moves and operates. So today we're going to go over the basics, and then over the next few days we'll jump into G&M programming, as well as some review on the machine control itself. I did over the last couple days upload an assignment called the American Precision Museum Clock. So make sure you guys get on and complete that assignment as well. So we're going to be working on both assignments kind of simultaneously here a little bit, but we'll jump in to the lesson here in just a second and review how a CNC machine operates and how it's controlled. Okay, so a CNC machine is a computer numerical control machine. It's capable of performing complex operations faster and more accurately and more consistently than conventional manually operated machines. Common machines are lathes and mills, but other machines exist as well, such as CNC water jet cutters, CNC lasers, as well as CNC surface grinders. Um, but for our purposes, we'll be focusing on mainly lathes and mills. Here's an example of a CNC lathe. This is a Haas tool room lathe, very similar to the one we have at school, except the older models did not come with a full enclosure, and they did have handles on the ends of the carriage and on the tool post to move the axis manually. Here's an example of a CNC turning center. So this one has a full closure and an automatic tool changer, much like you would see on like a CNC mill, but in this case we have CNC turning tools. Here's an example of a CNC milling machine. This is a Haas tool room mill. It does not have a full enclosure, but does have some guards here for chips, guarding from chips flying around. Example of a CNC machining center. Okay, so this does have a full enclosure and an automatic tool changer. Much bigger footprint than our CNC mini mill, but very similar operation and setup here. CNC programs are entered and stored in the machine control unit. The MCU controls all machine functions, including axis motion and accessories. So we'll get into some of the menus on that in the next few days. Components used to position a machine axis from program commands such as drive screws, ball screws, CNC guideways, and servo motors. These components are essentially what make CNC machine control possible. We'll take a look at a couple examples here of those different components. Here's an example of a ball screw assembly. So what you're going to have first is the actual ball screw itself, very much like a threaded bolt or threaded rod, but instead of having kind of that V shape, we're going to have this concave, nice curved shape to the screw thread. Inside of this ball nut, we're going to have ball bearings, and as the ball screw rotates, the ball nut moves very precisely across that ball screw. There's little to no play, end play in that ball nut. So very precise and very predictable, how far and how fast that ball nut is going to travel across that ball screw, which is dependent on how many threads and the spacing between the threads. But the essence of this is the ball bearings itself. That makes the precision movement possible. Here's an example of a linear guide. So we're going to have a carriage that is riding on a ball bearing assembly, and on a linear rail. That linear rail is going to lock that carriage in place vertically and horizontally, and provide a nice straight flat surface for, say, the machine table to travel across. CNC machines work on a coordinate system, so these coordinates specify positions for cutting tools on the workpiece. We're going to be using the Cartesian coordinate system, which has positive and negative values of x, y, and z axis. Here's an example of a servo motor assembly. We'll kind of skip over that for the moment, and we're going to jump right into the Cartesian coordinate system. So you can see that we have positive and negative values of x, y, and z with an origin there in the center. Now if we take a look at that from the top, it's going to look very similar to a graph that you might have to create in one of your math classes. We're going to have 4 quadrants: x minus y plus, y, x plus, y plus, x plus y minus, and x minus y minus. So here's a diagram showing the polar coordinate system. When using the system, the x value specifies the distance from the origin, and the y value specifies the angle relative to the 0 degree mark. So we have A at x8, and then the angle of y is 45 degrees. So the coordinate is going to be x8, y45. Now, using this and expanding on it, we can represent, say, a bolt hole pattern for a bolt pattern on, say, a flange of some kind, and we can represent where those coordinates are using that polar system. Now, jumping into positioning systems of the CNC machine, really when we get into G&M programming, you're going to see that there are these 2 positioning systems, absolute positioning and incremental positioning. Absolute is going to reference all of the positions relative to a single origin, and then incremental is going to specify a distance from the current position to the next. So what you're going to have to pay attention to when we go over G&M programming is the G codes that these are represented by. So an example of absolute programming, you can see that there's an origin there in the center, and points A, B, C, and D are referenced off of that origin. So say A is positive x positive 6, y positive 6. Similarly, we have the incremental programming system where we're going to have A, B, C, and D all represented a certain distance away from one another. So if we start at point A, point B is a certain distance from point A. So G&M codes are basically going to be telling the machine what to do throughout our programming. So a G code is a preparatory command. It's going to set machine modes. And the most common, obviously, is a motion of some kind. So a G code is going to initiate some kind of motion to a certain position on our machine. An M code, or miscellaneous function, is going to turn certain things on and off. So we can turn coolant on and off. We can turn our spindle on and off. And then we're also going to be using other word address commands. So we're going to be using letters to represent words or commands. So F for feed rate, S for spindle speed. We'll take a look at more of that in the next few days. We also have conversational programming. So, the intention of conversational programming is to simplify this whole idea of programming a CNC machine, we're not going to have to physically type out G&M codes, but what we'll do is we'll go to the machine control and select different functions. And those functions are going to have pre-programmed G&M codes that are going to allow us to, say, make a simple bolt hole pattern or machine some simple pocket to a certain depth and certain dimension. And all you're going to do is go to the machine and go to the correct menu to get to our conversational programming. Now we'll take a look at how a program is broken down. So the way we begin most CNC programs, the program is going to begin by the tool being loaded, the spindle being started, and the tool being rapid positioned at the first location. So in this example, you can see that we have a program number and a program name. The program name is going to be in those parentheses, and that's going to let the operator know what that program is going to be doing or what part it's going to be making, and the machine is going to be reading the program number. We jump into some G codes. You're going to see a G20 for our inch units and G94 for inches per minute feed units. We're then going to complete a tool change using M6 to tool 1, and then a G00 rapid movement in absolute programming to a certain set of coordinates. And then we're going to move the Z-axis down to 100 thousandths of an inch above the part. The spindle is going to turn on at 4,500 RPMs. This is going to be how we're going to start most every CNC program. Jumping into the next one, we've got the tool is fed to the depth, and then fed to each location. Once machining is complete, tool is then retracted to a clearance point above the workpiece. So we have a linear motion of G01 to Z negative 100 thousandths at a feed rate of 14 inches per minute. Once that is completed, we're going to jump to X and Y coordinates. That's still going to be using the G01 linear motion. And then we'll use G02 to make a clockwise arc to those coordinates. And then the Z is going to rapid up above the part to 100 thousandths of an inch to clear the workpiece. Next, the tool is going to rapid position to a location far above the workpiece. Coolant is turned off and the program is ended. So the M9 is going to turn the coolant off and the M30 is going to end the program. So there's a couple M codes. So that's going to do it for this part of our lesson. The next couple days we'll jump into a couple other things, and we'll catch you later, guys.